Let's do a little, before we do the problems on that sheet, let's do a little lightning round of functions speak, right? Let's say that this function represents, x is the time of day, and f is the number of fireflies I see, right? Not the show, but the bug. What would f prime of x mean? Well, what's the other way I can write f prime of x? What's the other way I can write it? What's the other way I can write it? No. What's the other way I can write it? The other way I can write that symbol, using the idea of the infinitesimal stuff. What does f prime of x represent? What does it represent related to f? It's the what of f? Slope of f. I like it. It's the slope of f. So if I had a graph of f, here's f. Where is f prime on this? And that's a weird question. It's not the right question to ask. If I said, where is f prime on this? It's a very strange way to ask that question, because how can you see f prime on this graph? Where's f prime? What is f prime? Slope. So where's f prime on the graph? Well, it depends on what the slope is at each point, right? It would actually be its own function. I can actually graph the slope of this. For example, what's the slope right here? 0. So I can put a point right there for the slope. The slope is 0 there. And I can go from there. I'm not going to go there yet, because that's a weird thing in its own right. Now, so how could I write this? Since it is slope, it's change in outputs over change in inputs. Let me make this a little f. Yeah, poor little dude. So what was f? What are the units on f? Number of fireflies, right? And what is the units on x? Time of day. So what's the units on f prime? The number of fireflies per whatever the time's in, hours, seconds, whatever. Okay, I like it. What if I had a function s of r, where s is the number of strawberries I see on all the bushes, and r is the row that I'm looking at for this row of strawberry bushes. Are you with me? So there's a row here, the number of strawberries you see there, and so forth. Now, this might be a little bit weird, but what would s prime of r be? It would be ds dr. So it would be the change in strawberries per the change in row. So if I notice, so this would be interesting, if I noticed there's like 30 strawberries here, and then 40 strawberries here, and then 80 strawberries here, and then 130 strawberries. I'm really interested in what's going on over here. It's like, is the water not flowing all the way up? Do you guys see what I'm saying? I see a definite trend up. I see a slope, a positive slope. As I move this way on the rows, I see my number of strawberries increasing. There must be something interesting over here, and not so interesting over there. A little bit desert conditions, a little bit tropical over here. I got to get that distributed better. You guys with me? Like maybe the irrigation just died over here or something. Okay, maybe. There's a connection with real life all the time with math, believe it or not. All right, so coming back to our worksheet. Let's see. Where did I put you? There you go. Let's start with number 2, just because we're there already, sort of. We'll come back and do number 1. So if I ask you the units on r prime of a or f prime of x or whatever prime of whatever, a really smart idea is to write it the other way. And this really mimics y2 minus y1, change in outputs over change in inputs. That is all that means. But if I put it like that for myself, the units kind of flow. So yeah, this is thousands of dollars in revenue per thousand spent on advertising. So that's the units there. So when we get to part C, so part B real quick, if it's positive, what does that mean? Say again?
The more expenditures, the more the revenue.
Good. As my advertising money is spent, it goes up, so does my revenue, right? That's what that means. It's positive, so as one increases, so does the other one. If it was negative, as one increases, the other one decreases. So this means that as I spend more money, on advertising, revenue goes up. Near A. The minute I get farther away from A, who knows what the slope is doing? So part C now, what does this mean? Now watch. Let me ask you a little bit different question. All right, here's what I ask you. What does this mean by itself? What is the difference between these two questions?
One is a function, one is a slope.
Yeah, this is the revenue function. This is still a function, but it's the slope of the revenue function. Right? What is the input for revenue? Advertising money, right? So what would this statement mean? When I spend $100,000 on advertising, I make $2,000. Right? That doesn't sound like a great deal, right? Thankfully, that's not where we are. The real question is this one. When I am spending already $100,000 on advertising, if I spent, let me see if you guys get this. What are the units on this again? Right there. So if I spent 2,000, no, let me see this. 2 to 1, right? Is that cool? I already got the units staring me in the face, so I can just marry those two together. What does a 2 mean for R prime? It means 2,000 revenue per 1,000 advertising. So it's predicting that if I spent another 1,000 on advertising, I should make another 2,000 in revenue. Will that definitely happen? Because the minute I spend any more money at all, I've moved on my revenue curve, haven't I? So the slope, I might be like almost to the top already, and then I move way over here, and now I'm down. That's why I don't want to take this big of a step. So how big of a step could I take instead? Maybe spend $100 more. It's predicting I should make $200 more revenue, or 200,000, or 200. That's right. Let's just stick with the hundreds. I like it. Or I could do $10 more in advertising, make another $20. At that point, it's like, no, that's not going to help the business out. $20. Woohoo! Do you guys see what's happening here? I mean, this is how you interpret results to a slope problem. So at a time when I'm already spending $100,000 on advertising, if I spent another $1,000, this predicts I would make another $2,000 in revenue. I like it. Now, of course, that's too big of a step, so I wouldn't take that big of a step. I'd be more cautious. I'd spend a little more in advertising and then reevaluate, see where I am. I like it. Okay, and again, this is all new shit to you. You got to let it sink in. Let's see. What about part D? I pretty much gave this one away. Right? Suppose a company plans to spend $100,000 on advertising, so they're in this situation. R prime 100 is 2. Should they spend slightly more or slightly less than $100,000? Because the whole purpose of a company is to make money. So if they want to increase their revenue, they should spend a little more or a little less. If they are spending $100,000 now and they spend a little more in advertising, their revenue should go up because this is positive.
But you were just mentioning that we don't know what the slope would be at, let's say,
I know. So that's why this is exactly why I use the word slightly more. Should they use slightly more or slightly less? They should spend slightly more money and then reevaluate, because this guarantees that they move up a little bit, they're going to get more money. It's just how big of a step do I want to take? So let me take small steps. Something called marginal revenue, if you do any business courses. Marginal cost, marginal revenue, marginal profit, they're all derivatives. Okay. The word derivative means something else in business, so don't go too far with that. Okay. So they should spend a little bit more, not less. Right? What would they want R prime to be equal to? What's the best place to be on this revenue graph? Let me not go crazy here. Where's the best place to be? This kind of sucks, Jeff. You made a horrible revenue graph. Let me see. So what's the best place to be on this revenue graph?
Where it equals 0. Where the slope equals 0.
Where the slope equals 0, thank God. Not where the revenue is 0. So like right there would be a good place to be, right? Now where else is slope 0? Oh shit. So you would like R prime to equal 0, because that could mean that's optimal conditions as far as revenue goes. Right? But you'd have to be careful, make sure you're not down here. Maybe make sure you're not bleeding money and go, well, that's good. But we're bleeding money, but that's good. No, you want to be there. Okay, so if it's positive, that means you're not spending enough money. You can spend a little bit more. If it's negative, you're spending too much money. We're going to rein it back in. Okay, maybe. Okay. So what about, let's see, we got just no time left, but look at number 1 real quick. What did you guys get for number 1? Which ones are negative slopes? Yeah, 4? Yeah, f prime of 4. And at 0 is negative, I agree with that. Positive slopes? Where are we at? Say. Negative 2? Yeah, negative 2 is positive slope. And 3 is positive slope. Any 0 slopes? Yeah, left one dude out. What does it look like? 2 is 0, yeah. So at least you got, so now you just would have, see, this is a really good first step on that kind of problem. Because now you just got to figure out between these two, which one's more negative, between these two, which one's more positive, and this guy is just sitting in the middle. Then you got it ordered. That's exactly how you can attack that problem. I like it. And we'll do number 3 next time, but it's basically just that y minus y1 business we were doing earlier. So officially, let's say this. We didn't get to 2.8, so 2.8 will not be on this first test. Everybody have a practice test, right? So I'll have a answer key for that next time. So this Thursday is going to be just review for the test. No new stuff. Test, of course, is next Tuesday. Monday's a holiday, so enjoy that.